Wow, the popcorn stays out for a minute, so please be quiet. Welcome, good afternoon. Please, who are you? Introduce yourself. What's your company? What you're doing here at TEQNation? Tell.
So my name is Guy Rose. Should I look awkwardly at the camera and say, hello everyone, my name is Guy Rose. I'm a developer advocate at Redis. I'm here at TEQNation giving a talk about probabilistic data structures. It's part of I've sort of found myself on this European tour by accident. Last week I was at Devox UK. Yesterday I was in Antwerp. I spoke at TEQNation, Belgium.
Wow.
Today I'm here at TEQNation. Tomorrow I'm flying to Milan to speak at Papers We Love. And next week I'll be in Oslo.
Wow, so this is a complete European tour for you.
So if I'm off my game, it's because I'm tired.
Well, I didn't notice yet, but to be, just for my curiosity, is it the same topic you're going to talk about in all Europe, or?
For the most part, yes. I've got 2 talks that are in circulation. I've got more than 2 talks in circulation, but 2 talks were accepted in this group. There's one on probabilistic data structures, which I'm giving today here in a couple hours. And I have another one on software-defined radio and Redis. So the software-defined radio one's a lot of fun because I have an antenna on stage and I'm holding it up, and it's picking up aircraft transponder data and shoving it into an event stream in Redis.
Wow.
And then I put it on a map. And basically, I rebuilt FlightAware using data from the air.
Live on stage?
Live on stage.
Wow.
Well,
that's
it's already
impressive.
coded.
That's impressive.
I didn't code it, but it's pulling live aircraft and feeding them onto the screen.
Yeah, okay, but still
in real
impressive.
time.
And today, your talk today?
It's understanding probabilistic data structures with 112,092 UFO sightings.
Wow, that's a lot of sightings.
It is.
And where did you gather all that data from?
So I always give credit to the guy who screen scraped the National UFO Reporting, I think it's Research Center. It's one of those sort of organizations that gather UFO data that's private, which means it's basically UFO fans, right?
Yeah. Fan data.
And they've got a big database of all these sightings that have been reported in. By database, we mean website that has lots of pages on it.
Yeah.
And so Timothy Renner is a data scientist. I think he's based out of Austin, who screen scraped all this data from their website and created a convenient CSV file that is 112,093 lines long because it's got a header. And I use that to as example data.
And you're using that to prove the power of?
So I'm using it to demonstrate how you can use probabilistic data structures. Specifically, I do a statistical analysis of the words used in the UFO sightings, which is to say that I count them.
Yeah.
And so I tear apart all the eyewitness accounts, all the sighting information. I saw a UFO and it was coming up over the mountains, and then they pulled me up in their tractor beam thing, and things happened that I don't want to talk about on a podcast.
Rather not.
Parse that all out, pull the stop words out, and feed it into a probabilistic data structure that counts which words are used. And then I can get an estimated count of the words. You get a reliable ranking of the most popular words in these sightings.
And can you give us a clue? What are the most popular words? Can you name a couple?
Well, it's not always the same when I run it because it's probabilistic, and so there is a degree of freedom. Probability in there, right? But popular words are night, sky, object, light, looked, or look, and words like that.
And you're using Redis to make this happen?
Yes, I am.
Okay, and does that help you a lot?
I don't. It's helped me come to terms with the horrible UFO sighting that I saw as a child. No.
Oh man.
Part of it's just a gimmick to show off what probabilistic data structures can do. In this particular case, I'm using a probabilistic data structure that Redis has built into it called top K. It's really a heavy keeper and a min heap. Heavy keeper is the specific data structure that's probabilistic. The min heap is just a heap.
Yeah.
But paired together, they call it a top K. And it's good for like doing trending topics and ranking things. but not necessarily giving you accurate counts.
Okay.
And so, but it does it quickly and compactly. And so you can feed 112,092 UFO sightings into it and still have the data structure only take up, a few K.
That's not much.
And so that's really what these data structures do is they take large volumes of data and they hash them away so the data's gone, but you can do counts and cardinality and test for the existence of them in fast, compact ways. So you save a bunch of space, you save a bunch of time, but you sacrifice a little bit of accuracy.
And how long does it take to compress those data, those kind of lines?
Well, you do it as you go.
Okay.
So the simplest probabilistic data structure would probably be a Bloom filter. It's a really simple one. Mm-hmm. And what it does is you can give it strings or data or blobs of data. We'll use strings just to keep it simple. And then it will tell you whether it's seen that before or not.
Yeah.
You add things to it, and then you can check and say, does this exist in the set? And it'll either say no, it doesn't, or it'll say probably it does, but sometimes it's wrong. But you can feed like 1 billion users into this thing, and it will still do it just as fast as if there were no users in it.
Nice.
And so that's the big advantage. It's really tools for scaling.
Yeah.
I mean, if you've got 1,000 users, you can do select star from users where username equals. You can get away with that.
Yeah.
But if you've got 10 million users, you're not selecting from a SQL database. You have to do something else.
Not. Yeah.
And here you could say, hey, Bloom filter, tell me, is this username taken or not? And it would either say no, go ahead and use it.
Yeah.
Or it would say probably, and you say, well, we're not going to have that user then. Or we already do. It doesn't matter.
Nice.
And so it's great for problems like that. You got large volumes of data you want to dedupe. It's good for that kind of stuff. They're really interesting structures.
And what's the biggest takeaway you want your audience to have after your session later on today?
Well, honestly, part of it's just that probabilistic data structure is kind of cool, and I want to use these. But really, my honest objective is people have been using Redis forever in internet terms, which is to say 10 years. But they mostly use it as a cache, and they mostly are just setting strings in that cache, right? They're just they'll call an API, cache that API to a string, results, and then get it back. And Redis can do a lot of other things too. And so what I'm really trying to do is highlight the idea that Redis is more than just a cache, that it does lots of different things.
So you want them to use the rest of the power of the tools as well?
Yeah. It's not about getting more people to use Redis, it's getting people to use more of Redis.
Very interesting. Well, I wish you the best of luck during your session later on today, and enjoy the rest of your conference. Thanks. Here at TEQNation. Hope to see you again.
Yeah, likewise. Maybe we'll see you at another event put on that. Maybe later this month.
Good luck in the rest of your European tour.
Yeah. It's been exhausting, but it's been fun.
Nice. Thank you so much.
Thanks a lot.